So problem number 4 is the daylight problem. It says the length of daylight, sunrise to sunset, is approximately a sinusoidal function of the day of the year. The longest day is around June 21st, and the 172nd day of the year. In San Antonio, Texas, the longest day has 14 hours and 3 minutes of daylight. The shortest day has 10 hours and 15 minutes of daylight. Write an equation expressing the length of daylight in minutes per day for San Antonio as a function of the day of the year. How much daylight is there on August 7th? Okay, so because it does say that we should do this in minutes per day, we should transform our longest day length to only minutes, the same as the shortest day length. Okay, so let's do this. So 14 hours and 3 minutes is the same as 14 times 60 minutes plus 3 minutes. It happens to be 843 minutes. This is the maximum. While 10 hours and 15 minutes happens to be 10 times 60, 600 plus 615 minutes. And this would be the minimum. Okay, so now we have a maximum, we have a minimum, we should start writing the equation. The amplitude, the value of A, is maximum minus minimum divided by 2. And that happens to be 114. The midline, y equals some value of D. The value of D is the average of the maximum and the minimum. Divided by 2. And that is 729. I just did it before in my calculator. Now, notice this, 729 is not exactly 12 hours. It's actually 9 minutes more than 12 hours. It just happens like that in San Antonio, Texas. Okay, the period, well, the independent variable here is the day of the year. So they're telling us on June 21st, if that's the 172nd day of the year. So the period is how often this repeats. Of course, it repeats every year. So, so the period is 365 days. That's what we're going to use. Okay, that means the value of B is 2 pi divided by 365. We're going to leave it just like that. And the value of C, if we use cosine, is simply when the maximum happens. June 21st, which is the 172nd day of the year. So our function for the length of day, I'm going to use an L, length of day that depends on the day of the year, time, I'm going to put the time in days, is value of A, 114, cosine, value of B, 2 pi over 365, times T minus 172, plus, 729. Okay, this would be our function. To find out how much daylight is there on August 7th, so this is the length of the day or daylight. I need to know what day of the year is August 7th. August 7th. Now, if June 21st is the 172nd, I know that June 30 which is just 9 days later, is the 181 day. And then July 31 is 31 days later, is the 212th day. And then August 7 is 7 days after that, is the 219th day, 219th day. So to find out how much daylight is then, I just have to go and say what's L of 219. So substitute 219 here and get that. Get that on the calculator. 14 cosine from 219 minus 132. It happens to be 807.679. We're gonna say 808 minutes. 808 minutes. Now, if I want to pass that to hours, I would have to say it's 13 hours. Let's see, divided by 60. Yeah, 13 hours. So 13 times 60, that is 780, and I'm still missing 28 minutes. So 13 hours and 28 minutes. Almost 13 and a half hours. What are the units of this? No. Oh, that's it. Write an equation for the derivative of the function in part A. Okay, let me change colors. The derivative of the length of day with respect to the day of the year is the derivative of this thing, which is 114 times negative sine of the same argument, 2 pi over 365 t minus 172 times the derivative of the inside, which is 2 pi over 365 plus 0. Okay, I'll put this one with the negative together. So that's 114 times 2 divided by 365 times pi. So that is negative L prime t is negative 228 divided by 365 pi sine of 2 pi over 365 times t minus 172. That looks like 1.72, but it's 172. What is that? Okay. So I got the derivative. At what rate is the length of day changing on August 7th? Okay, at what rate is the derivative on August 7th, which is the 219th day, 219th day. And we just substitute 219 here, and we get it. Let me get that. Okay, I get us an answer negative 1.420. Okay, negative 1.420. What does this mean? It says, what are the units of this rate of change? Okay, these are the units of L, the length of days, so these are minutes. Per the units of T, which is days, 2 minutes. So negative 1.4 minutes per day. So that means that during that day, each day is becoming has negative 1.4 minutes less of daylight each day at that moment. Part C, what is the greatest rate of change of the daylight length? Okay, I guess this was part B. And the whole thing was part B, the blue thing. And part C, we're gonna do it in purple. Greatest rate of change of daylight length, that is the greatest of L. And the greatest, we already know, is when the sign is negative, so it's going to be this value. Part C is going to be 228 pi divided by 365. Okay, which, if we wanted as a decimal, that's 228 divided by 365. That's 1.962, which is basically 2 minutes. 2 minutes per day. Minutes per day. Now, on what 2 days of the year is the rate equal to this number? Okay, this is when the sign is either 1 or negative 1. So, because when the sign is at its maximum or when it's at its minimum. If the sign is, if we do this, the sign of 2.365 divided by t minus 172 is maximum, that is on that is equal to 1. We apply the inverse sine to 1, and that is simply pi halves. In here, the sign cancels, so we get that 2 pi over 365 times t minus 172. Again, I wrote 1.72. It's 172. Must equal pi halves, because that's when the sign is equal to 1. Okay, the pi's cancel. We're going to multiply by 365 and divide by 2. And we're going to get the t and then add 172. So the t is pi's cancel. 365 divided by 4 plus 172. And this so happens to be 365 divided by 4 plus 172 is 263.25. I will say this on the 263rd day of the year, or is this 264th day of the year? It's a discussion for another time. And the sign is minimum. Sign is when it's equal to -1. 365 t minus 172 is equal to -1. If we apply inverses, we're going to get something very similar here. 365 t minus 172 is equal to negative pi halves. It's negative. So we get pretty much the same thing, but negative. T equals negative 365 divided by 4 plus 172. Okay, and that is 80.75. So I would say the 81st day. Now, 263rd day and the 81st day. And really, we should find out that this is during the equinoxes. The 81st day of the year should be March 21. And the 231st day should be September. I don't remember, is it 21 or 22? We would have to see. I think it's 21st. And that's it. Anything else to this problem? No. Okay. So